This is the first in a series of video recordings showcasing R and RStudio and the new ReLTER package in the context of the European Long-Term Ecological Research Network. The slides and all these scripts that we'll show are available on GitHub at this repository. We suggest that you start a new R project in RStudio by cloning the GitHub repository so that you will have on your computer all of the scripts and all of the slides that we're going to show here. This will allow future collaboration as well. Those that are already familiar with Git and with RStudio might skip this video. Those of you who want to read some extra background material, the first link here is to the Git book. The second is an explanation of Git specific to RStudio. And then a few further online resources regarding R in general. The first is the very well-known R for Data Science by Hadley Wickham. The second gives a good basic introduction to R from Norm Matloff. The third is where you can search out R packages. A few tips before we begin. It's recommended always in RStudio to start a new R project for each analysis. And it makes perfect sense if you're working together with other colleagues to open up a GitHub repository for your work, and then have the R project tied to that Git repository. And it's very easy to collaborate with colleagues. Now, when you work this way, all the problems of working directories and paths on different computers all go away. No need for working around with set working directory and all those workarounds. What's more, in RStudio, there's an option to save all of the data in a session continuously to RData, to an RData file. This is not recommended. As you're working along through an analysis, you'll be creating all kinds of temporary variables that might not be necessary for the analysis itself. You'll be loading extra packages, and if you're continuously saving the session to RData, then each time you reload, you'll be pulling in a lot of extraneous temporary things. Somewhere down the road, something won't work, and it will be very difficult to find what the source of the problem is. What's more, the Control-Shift-F10 keyboard combination is very useful in that it cleans out the current working environment. This way you can write a script, you test it, and then you can do Control-Shift-F10 to wipe out the environment and restart the script. That way you're always getting a fresh start. Highly recommended. Markdown is a document format that allows to combine code together with descriptive text and the outputs from the code. So an R Markdown document can be formatted to produce an HTML page or a PDF, or, as in this case, slides. That's a good way to collect your code and your descriptions into a report or demonstration. Where do we find R packages? The main central repository for all of the R packages is CRAN. This includes everything to do with mathematics and statistics and spatial and machine learning and so on. The second popular repository is called Bioconductor. Many of the packages on Bioconductor deal with environment, ecology, biology. The developers who are working on new packages often keep them on GitHub. For example, the ReLTER package that we'll get to in future videos currently lives on GitHub. And we'd also like to mention the R Open Science Platform, which has accepted the ReLTER package This is a platform that checks and validates packages and makes sure that the code and data stored there are open for scientific research. How do you install new packages onto your computer? Well, it's very simple. A call to the install packages function. And you pass to that function the name of the package that you want to install. By wrapping the function in an if clause, as appears here, that ensures that you won't reinstall a package that's already in your computer. Regarding Bioconductor, you begin by first installing the Biomanager package, like so. And then you use Biomanager install to install packages that are stored on Bioconductor. For example, here's the EB image manipulation package. What about Git repositories? For GitHub and other Git repositories, we begin with the remotes package. You need to have installed on your computer remotes, and then it's a call to remotes install GitHub with the name of the repository and the name of the package, like so. So this is how you will install in future ReLTER. Now, very quickly, you'll have hundreds of packages installed on your computer, but in any one analysis session, you will probably only need a few. So this is the way to load into a current session the specific packages that you want. First, you prepare a list of the packages that you need, like so, package list. And then you can use one of the apply family of functions. For example, here, lapply. You pass it the package list and a function to run on each of the packages, each of the items in the list. So in this case, require loads the packages one after another. When it returns true, that means the package is loaded successfully. Now, most ecological environmental research will be using spatial data. The spatial domain in R currently is handled by, first of all, for vector data, by the SF package, simple features, and by Terra. Raster data is also handled by Terra, and as well by STARS. STARS focuses more on space-time raster datasets. For visualization, there are several choices. You can choose TMAP or Leaflet or ggmap. ggmap is one of the ggplot family of functions. And it's worth mentioning that each of these packages also has a built-in plot function for doing quick plots of a spatial layer. It doesn't have all the fancy styling and so on as TMAP and Leaflet, but it's for a quick plot, it's very handy. Now, from 20 years ago and up until the last few years, the R spatial domain was handled by a set of packages that included SP, RGDAL, raster, and RGEOS. It's important to understand that these packages all are going deprecated. So if you find a tutorial on the web or some other package that depends on one of these, you need to be aware that probably within a year it won't work anymore. Regarding online resources in the R spatial domain, there's an excellent book, Computation with R, by Robin Lovelace. It's a full coverage of all kinds of spatial analysis using R. Highly recommended. The second book, shorter, but also a brief coverage, is rspatial.org. The blog, r-spatial.org, covers ongoing issues with the R spatial domain. Most developers who are working on and improving spatial packages keep them on GitHub. So it's a good idea to follow the GitHub R spatial category. Finally, for those who do well with mail lists. There are several different specific, what are called special interest group mail lists for R. And the special interest group for geographic issues is RSigGeo. We'd like to show a quick example now of how to use spatial data in R. We're going to install and load the package called GeoData. GeoData gives us a collection of global online data sets. For example, administrative boundaries from the GADM collection, precipitation, monthly precipitation, monthly temperature, minimum and maximum from WorldClim. Within GeoData, there's also access to land cover layers, for example. In this example, first we install the RSpatial GeoData package and load it with the library function. Then we're going to download the borders of Slovakia. Level 2 indicates that we want the province boundaries, not just the boundary of the country. Once we've acquired the boundaries of Slovakia, then we need to transform it to an SF class object. This is for plotting purposes. We'll see that in a moment. In addition, we'll download from WorldClim precipitation data. The WorldClim database, again, gives us 12 separate monthly averages of precipitation. After running this code, we can then display the results. We're using the TMAP package. By setting mode to view, TMAP gives us an interactive map in which we can display or not each individual layer. We use TM shape to load the boundary layers, give it a purple color. Then we use TM shape again to load from the Slovakia precipitation one of the 12 bands. Again, the WorldClim is a raster that contains 12 separate bands. It's a 12-band raster. We apply a palette of yellow, green, blue to the precipitation, and this is the result. Here's another example in which we load, instead of the first of the 12 bands, we load band 8, August. This is a precipitation raster for August, same area. Okay, now we'll switch over to RStudio. This is the RStudio application. Many of you are probably familiar with the upper left-hand pane that shows code. The lower left-hand pane is the console where code gets executed. The lower right-hand is a list of files. We're going to begin, as was suggested earlier, by starting a new R project. New project. We select version control and from a Git repository. While you weren't watching, I copied the link to the GitHub repository mentioned earlier. I'm going to give this new project a name. In this case, RStudio names the project and the directory the same, and it will be placed under my temporary directory, my working directory. When I press Create Project, then the repository is downloaded to my computer, and that gives me a copy of all of the scripts and all of the slides that we're showing in these videos. Now we've switched to this new project. For this first video, I'm going to open up the initial R script for demo number 1. That appears here in the code window. Whatever I select and run will be executed in the lower half lower left console window. Running on RStudio is a matter of pressing on the keyboard, Control-Enter. Of course, you can also select and click here on the Run button. So I'm stepping through the process of loading packages. Installing and loading. Here we're going to go ahead and install remotes and then the ReLTER package. Now I can set up a list of packages that I want to actually load into this session, then run lapply on that list to load them all. There we are. Now we continue on by installing the geodata package and loading it into this session. In geodata, there's a function, GADM. By putting a question mark, I get the help file, as you can see here. So GADM can take the name of a country and the level. Level 1 would be only the province boundaries. Level 0 would be only the country boundaries. Level 1 is subdivision. Level 2 would be an even lower subdivision. So let's run this line. This goes out to the internet, pulls down the GADM boundaries for Slovakia. Now let's see what we've got. The head function shows us the first few lines. We see we have an ID, country name, the province name, the district name, and so on. What class is this SLV? What kind of object is it? Well, it's part of the Terra package, and it's a spatial vector. Geodata downloads from all the different sites that it gives access to it, downloads into R as a spatial vector or spatial raster. For the sake of plotting, we need to convert it to an SF object. That's the function here. Now let's check what kind of object SLV now is. Class SLV. As you see, it's now become an SF class object. Now let's go ahead and get the precipitation data. Again, going out to the WorldClimb archive. And here I've downloaded a GeoTIFF file. Let's see what we've gotten. So it's the same package Terra, but in this case a spat raster. Now let's check quickly how many bands this spat raster has. Terra gives us a function nLayer. "12 bands. So it's an average precipitation for each month of the year. Now we'll go ahead and visualize. We use tmap, set the mode to view, and load both the boundaries and the precipitation. The boundaries get a purple boundary color. Precipitation gets a yellow, green, blue palette. Here you can see it becomes an interactive map where I can turn on or off as I wish either of the layers that were loaded. Automatically we get a legend. Let's do one more example. In this case, let's take a different month of the year. The dollar specifier allows me to choose any one of the bands. For example, I can take April, like so. We'll leave the palette the same. And we get a rainfall plot for April. And that concludes this session.